Hello friends, how are you? In this video lecture of crystal field theory, today we will see what is the JT distortion theorem, that is Jahn-Taylor distortion theorem. This is about geometry of given molecule. We know that geometry of molecule, geometry of complex depends on coordination number of metal. When coordination number of metal is 4, अगर किसी मेटल का कोऑर्डिनेशन नंबर 4 है तो उसकी ज्योमेट्री क्या होगी? स्क्वायर प्लेनर और टेट्राहेड्रल. Suppose coordination number of metal is 5. When coordination number of metal is 5, so trigonal bipyramidal. अगर मेटल का कोऑर्डिनेशन नंबर 6 है, coordination number of metal is 6, then geometry is octahedral or square planar bipyramidal. So it depends on coordination number of metal of that complex. लेकिन उसकी ज्योमेट्री रेगुलर है या डिस्टॉर्टेड है. So how to identify? So for this there is a JT distortion theorem. So to understand this, watch this video till the end. अगर आपको पसंद आता है तो like it, comment it, share it and subscribe it. So what is statement of this theorem? This is about non-linear molecule. Any non-linear molecule. So what is statement of this? Any non-linear molecule. लेकिन कौन सा? Which is in electronic degenerate state. Electronic degenerate state. It will be unstable. Will be unstable and will undergoes distortion, some kind of distortion in geometry. So it will undergo some kind of distortion. Why? To lower the symmetry, to remove degeneracy of the system, and to lower the energy of the system. So this is a statement of what? JT distortion theorem. This is for any non-linear molecule which is a non-linear and which is in electronic degeneracy and having same energy, always unstable. ये unstable होता है. To become stable, what happens? There will be certain kind of distortion in geometry to lower the symmetry, to decrease the energy and to remove degeneracy. So this is what? JT distortion theorem. In a simple language, this is about non-linear molecule. Tetragonal compression or elongation due to unsymmetrical electronic configuration either in T2G or AG. So we can write tetragonal compression or elongation. Tetragonal compression or elongation due to unsymmetrical filling of electrons in T2G or EG. T2G, we know that this is the term symbol for what? dxy, dyz and dxz. T2G and dxy, dyz and dxz. EG, this term symbol is for what? dx square minus y square and dz square. So why there is a distortion, why there is a compression or elongation in geometry due to unsymmetrical filling of electrons either in T2G or Ag. जब इलेक्ट्रॉनिक कॉन्फ़िगरेशन सिमेट्रिकल है, T2G भी सिमेट्रिकल है, Ag भी सिमेट्रिकल है, so they will equally repels all ligands. And equatorial bonds and axial bonds will be exactly same. That geometry will be regular octahedral geometry. अगर unsymmetrical filling है T2G either in T2G or Ag, then geometry will be distorted. So geometry, it will be what? Distorted octahedral. Suppose geometry octahedral hai, so it will be distorted octahedral. Now we'll see with examples. So here is the explanation of this JT distortion with examples. Here it is the D system. Strong ligands, when there is attack of strong ligands, when there is attack of weak ligands, and is there any distortion in geometry or not? Consider octahedral geometry. In octahedral geometry, coordination number is 6. When there is attack of 6 ligands, splitting of d atomic orbitals. Suppose system is a D1. System is a D1. इसका मतलब क्या है? इन D में एक इलेक्ट्रॉन है. जब लिगेंड्स का अटैक होता है, so d atomic orbitals, इसका splitting होता है. In splitting of d atomic orbitals in T2G and Ag, geometry octahedral है. So in octahedral geometry, we know that energy of T2G decreases and energy of Ag increases. क्योंकि Ag यानी dx square minus y square and dz square lies along axis x and y axis. And there is a direct interaction between ligands and that dx square minus y square and dz square. So here splitting, attack of ligand, splitting of d atomic orbitals, T2G or Ag. Suppose this splitting है, ये 5d atomic orbitals है, ये energy barrier center है, this is energy barrier center, this is for T2G or AAG. What is statement? Due to unsymmetrical filling of electrons in T2G and Ag, there is a tetragonal compression or elongation. This is this theorem. Now here only one electron is there. So after splitting of d atomic orbitals, जब अटैक स्ट्रॉन्ग लिगेंड्स का होता है तो 10dq, ये जो डिस्टेंस है ये 10dq है. जब स्ट्रॉन्ग लिगेंड होता है, वी नो दैट इन केस ऑफ स्ट्रॉन्ग लिगेंड, व्हेन देयर इज अटैक ऑफ स्ट्रॉन्ग लिगेंड, 10dq इज ग्रेटर देन नॉट पेयरिंग एनर्जी. अगर वीक लिगेंड है, पेयरिंग एनर्जी इज लेस देन दैट ऑफ व्हाट, ग्रेट मोर देन दैट ऑफ व्हाट, 10dq. In case of strong ligands, 10dq is greater than p. In case of weak ligand, exactly opposite, 10dq is less than pairing energy. So we'll see one by one. So here it is a D1 system. Here it is one electron. यहाँ पर एक electron है. So this electron will enter in T2G. यहाँ पर electronic configuration है T2G1 and EG0. सिमेट्रिकल है, अनसिमेट्रिकल है, दिस इज अनसिमेट्रिकल इलेक्ट्रॉनिक कॉन्फ़िगरेशन. एक इलेक्ट्रॉन है T2G में, अनसिमेट्रिकल इलेक्ट्रॉनिक कॉन्फ़िगरेशन. सो देयर विल बी डिस्टॉर्शन इन ज्योमेट्री. सो व्हाट इज स्टेटमेंट? टेट्रागोनल कंप्रेशन और elongation ड्यू टू अनसिमेट्रिकल फिलिंग ऑफ इलेक्ट्रॉन्स आइदर इन T2G और Ag. ये T2G1 है, सो डिस्टॉर्शन होगा. देयर इज अ डिस्टॉर्शन इन ज्योमेट्री. नाउ इन केस ऑफ वीक लिगैंड, in case of weak ligand, when there is attack of weak ligands, exactly same. Splitting of d atomic orbitals, here it is one electron, Ag, and here it is a T2G. ये इलेक्ट्रॉन भी यहाँ पर ही होगा, T2G1 इलेक्ट्रॉनिक कॉन्फ़िगरेशन T2G1 and Ag0. सो यहाँ पर ज्योमेट्री डिस्टॉर्टेड है, अनसिमेट्रिकल इलेक्ट्रॉनिक कॉन्फ़िगरेशन. यहाँ पर भी अनसिमेट्रिकल इलेक्ट्रॉनिक कॉन्फ़िगरेशन है. सो strong ligand में भी distortion होगा, and when there is an attack of what, weak ligands, there is a distortion in geometry, because in both cases electronic configuration is unsymmetrical, that is T2G1. Now I will take D2 system, and 2 electrons are present in d atomic orbitals. Again splitting, so here 2 electrons are there, splitting Ag and T2G. Now, in case of strong ligands, what is the relation? 10dq is greater than p. And the first 3 electrons compulsory enters in T2G. So both electrons will enter in T2G. Electronic configuration is T2G2 and EZ0. A empty है, dxy1 dyz1 dxz0 ये अनसिमेट्रिकल इलेक्ट्रॉनिक कॉन्फ़िगरेशन है, तो यहां पर डिस्टॉर्शन होगा. When ligands are strong, there is a distortion in geometry. There is a distortion in geometry. Now we'll check it in weak ligands. So in weak ligands, what happens? 10 dq is less than what? Pairing energy. Here it is T2G, here it is Eg. It is 10 dq is less compared to pairing energy. लेकिन यहाँ पर दो electrons है. Only 2 electrons are there. Both electrons will enter in T2G. Electronic configuration is T2G2 and Eg0. Symmetrical और unsymmetrical, A भी unsymmetrical है, तो यहाँ पर भी distortion होगा. Here ligands are weak. Distortion will be there. Now next one D3. अभी D3 यानी there are 3 electrons in d atomic orbitals. All these are degenerate. All these are degenerate. Here 3 electrons are there. If attack of ligands, strong ligands, here it is Eg and here it is T2G. This is the 10 dq. So both, all 3 electrons will enter in T2G. All 3 electrons will enter in T2G. So electronic configuration is what? T2G3 and Eg0. When there is attack of strong ligands, when system is a D3, it gives symmetrical electronic configuration. In T2G, in dxy, dyz, dxz, one electron in each atomic orbital. This is symmetrical electronic configuration. And remember, when symmetrical electronic configuration is there, there is a no distortion. So here, there is a no distortion when ligands are strong. When ligands are strong. Suppose ligands are weak, when there is attack of weak ligands, exactly same. In case of weak ligands also, electronic configuration T2G3 and EZ0. Symmetrical electronic configuration. Yani there is no distortion even when ligands are what? Weak ligands. Next. When system is a D4 and 4 electrons in d atomic orbitals, geometry octahedral, 4 electrons in d atomic orbitals, splitting of d atomic orbitals when there is attack of ligands, when there is attack of strong ligands, splitting, here 4 electrons are there, 1, 2, 3, 4. Ligands are strong and there is a more splitting of atomic orbitals. Here it is Eg and here it is a T2G. This is the energy barycenter. This is a 10 dq. 10 dq, that is 1 delta O. Now splitting of d atom, after splitting of d atomic orbitals, compulsory first 3 electrons will enter in T2G. Now what about 4th electron? Here splitting is more yani 10 dq is greater than that of pairing energy. यहाँ पर pairing के लिए कम energy लगती है. So what is the position of 4th electron? 4th electron will enter in T2G only, yani pairing of electrons here. because a 10 dq splitting is more, 10 dq is more. So fourth electron will enter in T2G for pairing of electrons. So what is electronic configuration here? Electronic configuration is a T2G4 and EG0. So this electronic configuration is unsymmetrical. This is not symmetrical because in dxy there are two electrons, in dyz there is one electron, in dxz there is one electron. So this is not symmetrical electronic configuration. This is unsymmetrical electronic configuration in T2G. So distortion. And here T2G is responsible for distortion, not Eg. We can say it is symmetrical. Eg, there is no electron in Eg, and dx square minus y square may be electron nahi, dz square may be electron nahi hai. So this is unsymmetrical. So there is a distortion in geometry when ligands are strong. Isn't it? And who is responsible for this? T2G is responsible for this distortion. Now attack of weak ligands. Attack of weak ligands. Here 4 electrons. Splitting of d atomic orbitals. Here it is Eg. Here it is a T2G. And we know that when there is attack of weak ligands, splitting is less. Yani 10 dq is less than pairing energy. यहाँ पर pairing के लिए energy ज़्यादा लगती है. So total number of electrons are what? 4. 4 electrons. After splitting up d atomic orbitals, compulsory 3 electrons will enter in T2G. Now tell me the position of 4th electron. Here attack of weak ligand, splitting of d atomic orbitals is less. What is the relation? 10 dq is less than that of pairing energy, and pairing के लिए energy ज़्यादा लगती है. So 4th electron will enter in Eg. So here electronic configuration is what? A T2G3 and Eg1. अब यहाँ पर T2G symmetrical है. In each T2G atomic orbital there is a single electron. But in case of Eg there is one electron, one atomic orbital is vacant. ये symmetrical है, लेकिन ये symmetrical नहीं है. And we know that there is a compression or elongation due to unsymmetrical filling of atomic orbitals either in T2G or Eg. यहाँ पर T2G symmetrical है, लेकिन Eg symmetrical नहीं है. And there is a distortion. When there is attack of weak ligands, there is a distortion. But who is the culprit here? Here it is Eg. So distortion is due to what? Eg. I will take D5 system. D5. And a total number of atomic orbitals are what? 5, and total number of electrons are 5. Attack of strong ligands. Splitting of d atomic orbitals, Eg. And here it is T2G. T2G. This is a 10 dq. When there is attack of strong ligands, we know that relationship between 10 dq and p. 10 dq and 1 delta, it is greater than pairing energy. So here 5 electrons. First 3 electrons compulsory enters here. Since 10 dq is more, pairing of electrons in not T2G. So 4th electron. Here it is a 5th. Eg vacant hai. Now what is electronic configuration here? Electronic configuration T2G5, Eg0. Now tell me symmetrical hai, unsymmetrical hai? This is unsymmetrical electronic configuration. T2G unsymmetrical hai. Eg electrons nahi hai. So forget about that Eg. So there will be distortion in geometry. Distortion in geometry when ligands are strong. And this is due to what? T2G. And a T2G is responsible for a distortion in geometry. Now, attack of weak ligands. Splitting कम होगा. Splitting is less. Splitting is less. ये 10 dq. 10 dq. Energy vary center. 5 d atomic orbitals with 5 electrons. Isn't it? Because energy of T2G decreases, in case of octahedral, energy of Eg increases. Compulsory 3 electrons enters in what? T2G. Compulsory. Now remaining 2 electrons will enter in Eg. Because what is the relation? 10 dq is less than that of pairing energy. And pairing energy is more. Pairing के लिए ज़्यादा energy लगती है compared to 10 dq. So remaining 2 electrons will enter in Eg. So what is electronic configuration here? It is a T2G3 and Eg2, and both are symmetrical. T2G is symmetrical and Eg is symmetrical. And when there is a symmetrical electronic configuration, there is no distortion in geometry. तो यहाँ पर distortion नहीं होगा. When ligands are weak, there is no distortion in geometry. So there will be regular octahedral geometry. When a system is defined, and when ligands are weak, then geometry will be regular octahedral. When a system is defined, when ligands are strong, then geometry will be distortion, and distortion in geometry due to what? T2G. In case of D6, when 6 electrons are present in D and attack of strong ligands, here are 6 electrons, splitting of d atomic orbitals when there is attack of strong ligands, here it is Eg and here it is a T2G. We know that this is 10 dq. So 10 dq is greater than P. Splitting ज़्यादा है, isn't it? Energy of T2G decreases, energy of Eg increases. After splitting of the atomic orbitals, compulsory 3 electrons will enter in T2G. First 3 electrons will enter in T2G. Now what about remaining 3 electrons? यहाँ पर splitting ज़्यादा है, 10 dq is greater than P. तो यहाँ पर pairing होगी. Pairing energy is less, यानी here pairing of electrons in T2G only. Electrons are paired, electrons are paired, electrons are paired. So electronic configuration is T2G6 and Eg0. So this is symmetrical electronic configuration, and all these atomic orbitals of T2G are equally occupied by electrons. dxy2, dyz2, dxz2. This is symmetrical electronic configuration. So there is no distortion in geometry. There is no distortion when there is attack of strong ligands. There is no distortion in geometry. In case of weak ligands, what is electronic configuration? Splitting of the atomic orbitals. Here it is T2G and here it is Eg. Splitting. Energy vary center. यहाँ पर 6 electrons है. Six electrons. Compulsory 3 electrons will enter in T2G. So here 10 dq is less than pairing energy. यहाँ पर pairing के लिए energy ज़्यादा लगती है. So remaining electrons and a 4th electron will enter in Eg. 4th electron. 5th in Eg. Now what is the position of 6? Now pairing of electrons in T2G. Electronic configuration is T2G4 and Eg2. Here it is symmetrical or unsymmetrical. T2G unsymmetrical, लेकिन Eg symmetrical है. So distortion होगा, लेकिन distortion due to T2G. Unsymmetrical filling of electrons either in T2G or Eg. So this is responsible for what? Distortion in geometry. So there is a distortion in geometry when ligands are weak. In case of D6 system. D7. And a 7 electrons present in d atomic orbitals. All these are degenerate d atomic orbitals. 1, 2, 3, 4, 5, 6, 7. Splitting of d atomic orbitals Eg. And here it is T2G. This is the energy vary center. This is a 10 dq. Since splitting is more, relation 10 dq is greater than what? Pairing energy. Compulsory 3 electrons will enter in T2G. Now what about 4th electron? Whether high spin complex or low spin complex, since 10 dq is more, splitting is more. So pairing of electrons in T2G and a formation of low spin complex. 5th, 6th, now 7th electron will enter in Eg. Electronic configuration T2G6 and Eg1. T2G6 is symmetrical because the D, that is T2G atomic orbitals are equally filled. 2 electrons in each atomic orbital. But Eg is unsymmetrical. Here it is 1 electron in what? Dx square minus y square. Dz square is empty. This is unsymmetrical. तो क्या होगा? Distortion in geometry. When ligands are strong, distortion in geometry. But due to what? Eg. And here Eg is responsible for what? Distortion in geometry. Now when there is attack of weak ligands, splitting of d atomic orbitals Eg, T2G. 10 dq is less. Compulsory 3 electrons will enter here. 1, 2, 3. 10 dq come hai. Pairing energy is more. So this is 4th, 5th, 6th and 7th. यहाँ पर 2 electrons है. Here 2 electrons and here it is 1 electron. So this is unsymmetrical. Electronic configuration is a T2G5 and Eg2. Eg symmetrical है. T2G unsymmetrical है. So there is a distortion in geometry when there is attack of weak ligands. But who is responsible for this? T2G is responsible for this. Next, when a system is D8, 8 electrons, splitting of d atomic orbitals. 2, 3, 4, 5, 6, 7, 8. Splitting of d atomic orbitals, here it is Eg, T2G. Ligands are strong and here it is a 10 dq is greater than pairing energy. 8 electrons are there, here 8 electrons, system is a D8. First 3 electrons will enter in T2G. 10 dq is more. So pairing of electrons in T2G. 4th, 5th, 6th. Now position of 7th electron, it will enter in Eg and 8th also in Eg. Isn't it? So what is electronic configuration? It is a T2G6 and Eg2. A T2G symmetrical है because each atomic orbital of T2G is equally occupied by electrons. 2 electrons in each atomic orbital. ये symmetrical है. Eg भी symmetrical है, equally occupied, 1 electron in each. यहाँ पर T2G symmetrical है, Eg symmetrical है. Distortion नहीं होगा. There is no distortion in geometry. There is no distortion in geometry because symmetrical electronic configuration. Now in case of weak ligands, T2G and Eg. In case of weak ligands, we know that 10 dq is less than pairing energy. High spin complex होता है. So compulsory first 3 electrons enters in T2G. 4th, 5th, 6th, 7th and 8th. यहाँ पर भी exactly same electronic configuration है. T2G symmetrical है, T2G6 and Eg2. And there is no distortion. And geometry will be regular. And there is no distortion in geometry when there is attack of weak ligands. In case of D8 system, it doesn't matter whether ligand is strong or weak. Geometry will be regular octahedral. There is no distortion because electronic configuration is symmetrical in T2G as well as in Eg. In case of D9 system, here splitting of atomic orbitals, T2G and Eg. First 3 electrons enters in T2G. Strong ligands in 10 dq is greater than pairing energy is less. 4th, 5th, 6th, 7th, 8th and then 9. Electronic configuration is a T2G6 and Eg3. ये symmetrical है लेकिन ये symmetrical नहीं है. Because in T2G each atomic orbital is occupied by what? 2 electrons. In case of Eg, in dx square minus y square there are 2 electrons and in case of dz square there is 1 electron. This is unsymmetrical feeling. So there is a distortion in geometry. Geometry distorts. When ligands are strong, there is a distortion in geometry. And who is culprit for all this? Who is responsible for this? Eg. Eg is responsible for this. Now, when there is attack of weak ligands, T2G and Eg. When there is attack of weak ligands, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Exactly same electronic configuration, T2G6 and Eg3. Here a distortion in geometry. So when ligands are weak, and who is responsible for this? Eg again. So unsymmetrical electronic configuration in Eg when there is attack of strong as well as weak ligands. So distortion in geometry will not be regular. And in case of detained system, in both cases electronic configuration will be symmetrical, that is T2G6, Eg4. Even when there is attack of weak ligands, T2G6 and Eg4, geometry will be regular and there is no distortion even when there is attack of strong or weak ligands. So geometry will be regular. So tetragonal compression or depression due to unsymmetrical filling of electrons in T2G or Ag. This is said to be Jahn-Taylor distortion. Example of this distortion, I will take complex of copper with ammonia, hexaamine copper 2. ये कॉम्प्लेक्स है, यहाँ पर मेटल है कॉपर. What is coordination number of this copper? Coordination number of copper is what? 6. And जब coordination number 6 होता है तो उसकी geometry क्या होती है? Octahedral. So geometry is what? Octahedral. Now we'll see whether it is a regular octahedral or distorted. It depends on electronic configuration of copper in this complex. यहाँ पर कॉपर के ऑक्सीडेशन स्टेट क्या है? व्हाट इज ऑक्सीडेशन स्टेट ऑफ कॉपर? अमोनिया न्यूट्रल है. सो दिस +2 डायरेक्टली प्रेजेंट ऑन दिस कॉपर एंड यहाँ पर Cu+2 है and copper is present in +2 oxidation state. We know that electronic configuration of copper here argon 3d10 and 4s1. This is the electronic configuration of copper. Anomalous behavior about this electronic configuration, 3d10 and 4s1. Now what is the electronic configuration of Cu+2? Argon, now 3d9 and 4s0. +2 and remove up 2 electrons, 1 electron from 4s and 1 from 3d and 3d9 and 4s0. So system is a d9, and just we have seen when a system is a d9, there is a distortion in geometry. So what is the electronic configuration? Just we have seen when there is attack of strong or weak ligands. Ammonia is a moderately strong ligands. What is electronic configuration after splitting of d atomic orbitals? T2G6 and Eg3. In both the cases, strong as well as weak ligands. So this is symmetrical electronic configuration. ये symmetrical है क्योंकि dxy2, dyz2, dxz2 ये symmetrical है. And in case of Eg, यहाँ पर dx² - y² 2 and dz² 1. And this is unsymmetrical है. So Eg is unsymmetrical. So which set of d atomic orbitals is responsible for a distortion? Eg is responsible for a distortion in geometry. So geometry of this complex is not regular. Geometry of this complex is a distorted octahedral. So this is not regular. So geometry will be what? Distorted octahedral. Distorted octahedral geometry in case of hexaamine. What is the name of this? Here it is hexaamine. Copper 2 ion. इसकी geometry distorted octahedral. Now, unsymmetrical electronic configuration in Eg. यहाँ पर दो पॉसिबिलिटीज है. फॉर एग्जाम्पल, when unpaired electron is present in dz square, ये एक पॉसिबिलिटी है. This is one case number one. In case of dx square minus y square, here two electrons, and in dz square there is one electron. Both these are degenerate. Energy of dx square minus y square and dz square exactly same. What is second possibility? Second possibility, when unpaired electron is present in dx square minus y square, and paired electrons are present in what? dz square. So what will happen? I will take case 1. What is the case 1? When unpaired electron is present in dz square, dx square minus y square 2 and dz square 1. So unpaired electron is present in what? dz square. Geometry octahedral. Geometry is what? Octahedral. So what will happen here? I will take case number 1. Here case number 1. When unpaired electron is present in dz square, here in dx square minus y square 2 and unpaired electron in dz square, here this is unpaired electron. In dx square minus y square, electrons are paired. Octahedral geometry, square planar, bipyramidal. So suppose a square planar bipyramidal, suppose a regular geometry, here it is the metal, here Cu plus 2. These are equatorial bonds and these are axial bonds. At every corner there is a ammonia, and there is attack of 6 ammonia ligands. Here it is ammonia. This is x-axis, this is y-axis, and this is z-axis. What is shape of dx square minus y square? Shape of dx square minus y square lies along x and y axis, and dz square lies along z axis. Here unpaired electron is present in dz square, it is unpaired electron. In dx square minus y square, electrons are paired. Electrons are paired. So what will happen? Since electrons are paired in dx square minus y square, so dx square minus y square repel all 4 ammonia ligands away from it. Ammonia को repel करेगा. Equatorial. These are equatorial bonds and these two are axial bonds. So dx square minus y square ये repel करेगा ammonia को. Isn't it? So there is a force of repulsion between 4 ammonia ligands and this pair of electrons in dx square minus y square. यानी elongation of equatorial bonds. And when there is elongation of equatorial bonds, what happens? There is a compression between this metal and axial ammonia. And here it is unpaired electron. A little force of attraction between dz square and what? These two ammonia. There is a compression in geometry. Elongation of equatorial bonds and a compression about what? Axial bonds. तो यहाँ पर क्या होगा? ये here equatorial bonds, and in this geometry what will happen? Elongation will take place. ये metal है, these are equatorial bonds and these two are what? Axial bonds. यहाँ पर ligands like this. Equatorial bond suppose A and axial bond suppose B. तो यहाँ पर repulsion between equatorial ammonia and dx square minus y square, elongation of equatorial bonds, and here A is greater than B. Compression. ये compression है. Isn't it? Compression, tetrahedral compression. So here formation of 4 long bonds. Formation of what? 4 long bonds and 2 short bonds. Isn't it? When unpaired electron is present in dz square, formation of 4 long bonds and two short bonds. Here equatorial bonds are greater than that. When a bond length of equatorial bonds, it is greater than that of what? B. Now what is the case 2? Case 2. When unpaired electron is present in dx square minus y square. ये unpaired है and dz square. यहाँ पर दो electrons are paired. Now here electrons are paired and here electron is what? Unpaired. So there is a repulsion between what? Dz square and these two ammonia. Isn't it? Elongation. And a formation of two long bonds. Simultaneously there is a compression of what? Equatorial bonds. In the second case, what happens? Formation of, when unpaired electron is present in dx square minus y square, formation of two long bonds and four short bonds. So geometry क्या होगी? So here it is like this. Here it is copper, that is Cu plus 2, equatorial bonds, ammonia and axial ammonia. So here elongation of what? Axial bonds and a formation of two long bonds and four short bonds. तो यहाँ पर क्या होगा? यहाँ पर A is less than B and equatorial bonds A and axial bonds B. Equatorial bonds small है and A is less than that of B. So what is the conclusion? Unsymmetrical electronic configuration is responsible for this tetragonal compression or elongation. In case number 1, when unpaired electron is present in dz square, isn't it? So there is a compression and a formation of equatorial bonds, 4 equatorial long bonds and 2 axial short bonds and a compression. Case number 2, when unpaired electron is present in 1, that is the dx square minus y square, and when paired electrons are present in dz square. So what happens? So there is a elongation and a repulsion between these two ammonia and dz square. Elongation of axial bonds, and here formation of two long bonds and 4 short bonds. So this is said to be what? Agitated distortion. What is the conclusion? Unsymmetrical electronic configuration either in T2G or AG is responsible for tetragonal compression or elongation. If any doubt, you can put your doubt in comment box. Definitely I will get back to you.